Hello sir, myself Ankush Das.
Hello sir, myself Abhirup Roy.
Hello sir, myself Adarsh Kumar.
Hello sir, myself Anushka Das.
My name is Anubhav Sahoo.
So our topic was of constructing a speedometer using a solar cell and a speed. So here is our setup. So basically we have attached the solar panel over here, and in front of that we have attached the CD to the motor using a propeller for attaching it to fixed at a point. And here we have given a cut channel in the CD. So from here the light will pass, and we have placed the light so just behind the CD over here. Over here is the CD, and here we will power that this 9-volt light using a 9-volt battery, DC battery, and we have connected the DC motor using to that DC power supply present over here, and we will change the voltage supply according to our requirements. So let us show how this works. And before that, before going to how it works, let me tell you, the solar cell will generate the energy from the light, and then to measure the frequency of the light or to measure it, we have constructed a DIY oscilloscope at our home using a 3.5 mm headphone jack, and by giving it some resistance to reduce any damage to our mobile phones. So let's start and show how it works. So basically, so from here we will give it the voltage as per our requirement, and here our motor starts. And now we will turn on the this light using our battery, and here we can see that when the motor is rotating, at every point when the motor comes in direct in perpendicular line to the light energy, we will get the light to reflect on the solar cell, and the solar cell will generate an energy, and that energy we can see in the oscilloscope present in the reading. As you can see, every time it's rotating, it's giving a reading. So when we give the power supply to the motor, and when we give the power supply to the light using our DC battery, so when the motor is rotating and the cut channel is just passing through in front of the light source, the light is falling on the solar cell, and at a particular small amount of time the channel rotates and comes in front of the solar cell, and when the light passes through it generates electricity, and the signal we get in the signal it generates, we can see it in our software. The software name is AR oscilloscope. We can easily find it in Play Store or App Store. So from here in the software we can see the peak value, the V maximum, V minimum, and the period and the frequency, which we can read over here, and this is how the graphs is looking.